Good morning to all. Myself Vinod Kumar, Assistant Professor, Department of Civil Engineering, Rohini College of Engineering and Technology. Today we are going to learn a topic, continuous slab. In this continuous slab, we will see a problem. The design a one-way slab for an office floor which is continuous over T-beam at a 3.5 meter interval. Assume a live load 4 kN per meter square. Adopt M20 grade concrete and Fe 415 steel HISD bar used. First step is given data. Here L is equal to 3.5 meter, that is length. Then load Q is equal to 4 kN per meter square, and then FCK is equal to 20 Newton per mm square, and then Fy is equal to 415 Newton per mm square. And then second step is depth of slab. Assume a span by depth ratio is 26. This value is taken from class 23.2.1 IS 8456 2000. Here effective of D is equal to span by 26. The span is equal to 3.5 meter, that is 3500 by 26, that is 135 mm. Hence adopt D is equal to 140 mm, and then capital D is equal to overall depth. Overall depth is equal to 165 mm. Then second step is, and the next step is load calculation. First one is self weight of the slab, that is L into B into D into density of concrete, that is L is equal to 1 meter, and then B is equal to 1 meter, and then capital D is equal to 0.165 into 25, that is 4.125 kN per meter square. And the floor finish values assume, that is 0.875 kN per meter square, and the total working load, that is G, is equal to 4.125 plus 0.837, that is 5 kN per meter square. And then calculate the value with 1.5, that is we will get the design load, that is calculation. Referring table 12 and 3, that in from IS 456 2000 code, the maximum negative bending moment at support next to the end support is mu negative is equal to 1.5 GL square by 10 plus QL square by 9. By substituting the value 1.5 into 5 into 3.5 square by 10 plus 4 into 3.5 square by 9, that is 17.35 kilonewton meter. For positive bending moment at center of the span, the formula is mu positive is equal to 1.5 G L square by 12 plus Q L square by 10, that is 1.5 into 5 into 3.5 square by 12 plus 4 into 3.5 square by 10, that is 15 kilonewton meter. The next step is shear force calculation. The maximum shear force will occur at the support. The formula is Vu is equal to 1.5 into 0.6 into G plus Q into L. While substituting the formula 1.5 into 0.6 into 5 plus 4 into 3.5, the value is 28.35 kilonewton. And the next step is check for depth. Mu limit is equal to 0.138 FCK BD square, that is 0.138 into 20 into 10 power 3 into 140 square into 10 power minus 6. The value is 54.1 kilonewton meter. And then compare mu and mu limit. Here mu is less than mu limit. Hence this section is under reinforced section. And the next step is reinforcement details, that is mu is equal to 0.87 FYAST D into 1 minus FYAST by FCK BD. In this formula we can get the AST value. So AST is equal to 360 mm square, and let us provide 10 mm dia bar at 150 mm center to center distance. The same reinforcement is provided at the positive bending mid span. And then distribution steel, take 0.012 percentage of AST, that is 0.002 by into 1000 into 165, that is 198 mm square. Let us provide provide 10 mm dia bars at 300 mm center to center, that is 262 mm square. The next step is check for shear stress. The formula is tau is equal to Vu by BD. Vu value is 28.35 into 10 power 3 divided by 140, that is 0.2 Newton per mm square. And then calculate the percentage of steel. The formula is 100 into AST divided by BD, that is 100 into 262 divided by 1000 into 140. The value is 0.18. And the tau C value is taken from IS 456, and compare tau C and tau V. The value is tau C is greater than tau V. Hence the slab is safe against shear. Here the reinforcement detail of a diagram. The length L is equal to 3500 mm, and let us provide a 0.3 into L, that is 10 mm of 150 mm reinforcement at the top, and in the bottom let us provide 10 bars of 300 mm center to center distance. The width of the slab is 165 mm. Thank you.